This is about how you do inverse trig functions. So, like for instance, let's say I was solving this. This isn't a trig function, I know, but just to kind of get your bearings. Suppose you had x squared minus 17 equals 0, and you were solving for x. You get x squared equals 17. And then to find out what u squared to get 17, you would go to your calculator and push the square root of 17. So where's my calculator? There it is. So then I would say second and square root of 17. But it's only going to give me the positive answer, which is 4.123. But the real answer is plus or minus 4.123. So like when you decide to use the square root button, the inverse of x squared looks like this. So I know when I do x squared equals 17, there should be two answers. But when I use the inverse of squared and square root, it follows along only this part and gives me one answer, which is 4.123, but the answer is plus or minus 4.123. So like my point is, if say I didn't know this, and if I asked my calculator, it's only programmed to give me the positive one. It doesn't give me the negative one. So now what happens is if you want to know the sign of an angle that equals 1/2, there's an infinite number of angles, 30-degree reference angles, that give you a sign of 1/2, but your calculator is only programmed to give you one of them. And so you have to know which one it is. So there's many answers to this, but if you use what's called inverse sign, which a lot of you have already used, it'll only give you one answer, which y'all practiced on the other day. And then you might have to, depending on the question and how it's asked, you might have to say more. So here's the rules. Like if you just see square root of 16, you say 4. If you have x squared equals 16, you have to say plus 4 and negative 4. So with inverse sign, it depends on if you're on the regular function or the inverse function. On the inverse function, if it's actually stated that way, you only answer one question. It can get kind of tricky. Like for instance, if I say inverse, let me check my mode. I'm going to be in degrees for a minute. Some of your homework will be done in radians. So if I go inverse cosine of the cosine of 240, you know, common sense would try to tell us that these will cancel each other out, but we'll look at what the answer is. It's 120. It's not just cancel out. It's the same reference angle. So let me explain to you how it works. And then we'll do a bunch without our calculator. All right, so here's the rules. You need to put this on your memo page. So I'll pause for a minute while you get out your memo page. All right, inverse trig functions. Or if you still hadn't gotten your memo page out, you can pause. So if you have inverse sine or inverse tangent, what you do is you give your answers from only quadrants 1 and 4. Inverse cosine, when you're looking for an angle, and you use inverse or arc. These are interchangeable. Inverse sine of a ratio to find an angle is the same thing as saying arc sine. So I may say either one. But inverse cosine comes from only quadrants 1 and 2. So I'll pause for a minute while you write that on your memo page. Or again, you can pause the video if you're moving faster. Okay, now this was like set in stone, all of this a long time ago, and also this is how they programmed our calculators. This is why, if you actually are going to ask this question, You could list them forever and ever and ever. The first thing that comes to mind is 30 degrees, and that's sort of how they programmed your calculator. So what happens is sine is positive. All students take calculus. Cosine is like this. And you already know this. Tangent is like this. And so what they did was they said, okay, these two quadrants are together. And so if you are looking for a positive angle, we'll go this way. A negative angle, you go straight down. Like you're not even allowed to go around like this to get into the fourth quadrant. You have to go either up into the first or down into the second. You and your calculator will both do that. Tangent also, these are together, so it goes up into the first quadrant to 90 or down into the second quadrant to negative 90. They didn't do that with cosine because that would only allow for positive answers. So for cosine, we go from 0 to 180 or from the first to second quadrants, like that. All right, so this is, and what I'm talking about is if it's already got the inverse trig function on it. So you have to look at how it's worded. Just like how this is worded. If I ask you this, you should answer 5 and negative 5. If I just ask you this, I'm already on the square root function and your answer is just 5. So it depends on if you're in the inverse function or the regular function. Okay, so let's do some. If I have arc sine or inverse sine of 1/2, okay, according to all of this up here, I look in quadrants 1 and 4. So as I scan through quadrant 1, I find my answer right away at 30 degrees, or if I'm in radians, I would say pi over 6. The next one is inverse sine of negative 1/2. All right, so I'm only allowed to look at quadrants 1 and 4. So if I look in quadrant 1, sine is positive, so I have to turn around and look this way, and the answer would be negative 30 degrees or negative pi over 6. And again, I would count off if you went like all the way around, because they only went up and down on the sine curve like this. Here's a sine wave. And so this is up to positive 90, and this is down to negative 90. And that's what we're looking at. Before 0 and after 0. Same with tangent. Cosine looks like this. And so there's no reason to look before 0 and after 0 because those are the same numbers. So with cosine, we go halfway from 0 to pi or 0 to 180. And then everything just starts to repeat. All right, some more problems. Arc cosine or inverse cosine of 1/2 is a 60-degree angle. And you're going to look in the first and second quadrant. As you scan through, you find it right away in the first quadrant at 60 degrees, or if you're in radians, you would say pi over 3. What if you have arc cosine or inverse cosine of negative 1/2? You look in the first quadrant and don't find it. And so you continue on to the second quadrant where cosine's negative, and you get this 60-degree angle here, which is 120. So let me show you what I mean on the calculator. Because it's programmed the same way that we're programming ourselves right now. Inverse cosine or arc cosine of negative 1/2. It's going to go looking through the first quadrant. It's not going to find anything because it's got to go into where cosine's negative. So it'll find one in the second quadrant and spit it out and keep on going. And then it'll stop, and that'll be your answer. All right, the next one that I'm doing is arc tan of 1, or inverse tan, either one. This is the same thing. All right, so arc tan and arc sine, you're looking in the first and fourth quadrant. So I'll look in the first quadrant, I'll find my answer at 45 degrees. Arc tan or inverse tan of negative 1. Arctan, you can look up here or down here. Since you're looking for a negative, you would go down here, and the only answer we would accept is negative 45 degrees. Again, you could try to punch it in your calculator and see the same thing. If I have inverse tan of root 3, then I'm going to look in the first quadrant, and I'm going to find my answer at 60 degrees, or pi over 3. Arctan of negative root 3. I'm not going to look up here, so I'm going to look down here and get negative 60 degrees, or pi over 3. If I have arc cosine of negative square root of 2 over 2. Arc cosine, it doesn't do any good to look up here and down here, because cosine's positive in both of those places. So following the rules that are now on your memo page, you bypass the first quadrant with cosine, you go into the second quadrant, and you get this 45 degree angle, which is 135, or in radians, 3 pi over 4. And so that's how you do inverse trig functions. You'll have some homework on that. The point of them is that, say I'm doing sine of theta, let's say 3 sine theta minus 1, like last night's homework. So I have 3 sine theta equals 1, sine theta equals 1/3, which is possible, it's just not one that we memorize, so we've got to depend on our calculator. And so I'm going to have to find my angle by going inverse sine of 1/3. And now when I go to my calculator, I know this has only been programmed to kind of give me some help, not to answer my question. So if I go inverse sine of 1/3, if I'm in degrees or radians, it gives me 19.471 degrees. Okay, so what happened was I ran into something I didn't know, and I'm really actually trying to solve this question. That's a star. Trying to solve that question, but I had to use this key on my calculator. And all it did was look in the first quadrant and spit out an answer because it was positive. But it's my job to also pick up this answer. So this is a 19.471 degree angle. And so think to yourself, which you've already done in class, there's another answer from 0 to 360. It would also be this one, and it's up to you to find the other one. So my calculator is only able to give me this one. So now I'm going to say 180 minus this number, and I get 160.528 or 0.529. Okay. And so I found the two that are in the quadrant. So I used my calculator, and all it did was find the one in the first quadrant, because it'll only check 1 and 4. So I take that angle, and then I also use my reference angle to find the other one, to actually solve the whole thing on 0 to 360. If I was working in radians, I would have subtracted it from pi on my calculator. And we'll do some more of that in class. So here's the rules. If you have something like this, you'll use your calculator to find theta, but it'll only give you the first theta that you need. You need to use your calculator to find any others that are important. If I ask it like this, though, you only give one answer. If I put you on the arcsine function, I put you on that limited function. Just like if I put you on the square root function, it's limited to only positives. And so we would say arcsine of 1/7. Okay, and if we were doing 8.213, all right, so if we were doing this problem, it would be just the first one of our answers. I forgot what it said. 8.213. And I think I'm in degrees still. So then I'm going to subtract it from 180 because sine is positive here and here. And inverse sine can only find me this one. But if it's asked this way, your only answer is 8.213. So if you're on the inverse trig function, you obey these first and fourth quadrant for inverse sine and tangent, and first and second quadrant for inverse cosine. Homework, let's see, make sure I've done everything you need to see. Because you'll have some to put in your calculator. And let's do some of these, what are called composite functions. Suppose I have the sine of the arc sine of 1.7. I'm sorry, 0.7. It couldn't even be 1.7. Alright, so you really don't even have to work this out. The answer is 0.7 because of this. You would go to your calculator and you would go arc sine of 0.7. It would find you an angle. You would turn around and find the sine of that angle, and it would be 0.7. Or you could punch it in your calculator and see. What if I have this? Arc sine or inverse sine of the sine of 3 pi. Look what's on the outside is arc sine. The answer to arc sine can't go pi to pi. It can't be 3 pi. Arc sine can only come from here or here when you fill it in. So let's work it from the inside out. So we have to work this out. Sine of 3 pi, right here, your y value would be 0, so this is 0. And so the answer to this is 0, the answer to this. Then you say arc sine of 0, so now you go looking for something that gives you a sine of 0, and you find it at 0 degrees, or in fact 0 radians, because this one was in radians. Let me show you what I mean. Arc sine, what did I have? Arc sine of the sine of 3 pi. And let me change my mode. Let's go to radians because that's what I'm working in now. And it'll tell me 0. So if I do something like arc cosine of the cosine of 3 pi over 4. The answer will actually be 3 pi over 4. We'll talk about why. You may not know, but that's 3 pi over 4. Let me show you. See? All right, now how did I know that was this? If I have arc cosine or inverse cosine of the cosine of 3 pi over 4, arc cosine can come from quadrants 1 and 2, going this way, and this is in one of those quadrants, so the answer is 3 pi over 4. As opposed to if I have inverse cosine of the cosine of 5 pi over 4, the answer to this final question can only come from the first and second quadrant, whereas this angle is in this quadrant, so let's work it from the inside out. The cosine of 5 pi over 4 is negative root 2 over 2. And when I take inverse cosine of negative root 2 over 2, I go looking for an angle, and I find it right here at 3 pi over 4.